Today we're going to continue our discussion on solving logarithmic and exponential equations. In example 4 says solve each equation, round to the nearest hundredth. If you notice the numbers 15 through 19, these are exponential equations. Now refer to page 192 in your textbook, example 4, and they will also go step by step with how to solve these types of problems. Okay. Just as we did when evaluating, if you're given an exponential equation, you need to change it to a logarithmic equation. Okay? In number 15, we are going to log both sides. So remember, whatever you do to one side of the equation, you have to do to the other side. So I'm going to take the log 3 to the x power equal to log 7. Now that we have a logarithmic equation, we can use the properties of logarithms. I'm going to start with the power property, and I'm going to move the power that's x out to the front of the log. So I have x times log 3 equal to log 7. And then to solve for x, I can divide both sides by log 3. Okay, log 3 divided by log 3 is 1, and we need to take our calculator and calculate log 7 divided by log 3. Okay, so on your calculators, we're going to take the log 7, close the parentheses, divide that by log 3, close the parentheses, and hit equal to, and to the nearest hundredth, x is approximately 1.77. Now, I tend to use the common log when I have a base that is a number like 3 or 5. Now, in problem number 16, we have e to the power 2x plus 1 equals 8. So same thing, I'm going to isolate the exponent. Notice the exponent is already by itself. All I have is the base and the power. So then I'm going to take the logarithm of each side of the equation. Because this log has base e, I'm going to take the natural log of both sides. So I'm going to go the natural log of e to the 2x plus 1 power is equal to the natural log of 8. Yeah, now that I have a logarithmic equation, I can use the properties of logs. I'm going to begin with the power property, and I'm going to move the 2x plus 1 in front of the log. So I have 2x plus 1 times the natural log of e is equal to the natural log of 8. Now, the natural log of e is equal to 1, because this is asking me e to what power is equal to e. Well, e to the first power is equal to e. So this is equivalent to 1, and 2x plus 1 times 1 is just 2x plus 1. So we have 2x plus 1 is equal to the natural log of 8. Now I'm solving for x as I would in any basic equation. I'm going to subtract 1 from both sides first. So 2x is equal to natural log of 8 minus 1. And then I'm going to divide both sides by 2. Okay, so I'm left with x is equal to the natural log of 8 minus 1, all divided by 2. And once again, I have to plug this into the calculator to come up with a value. So I'm going to take the natural log of 8, close the parentheses. I like to go ahead and hit equal to and get a value. And I'm going to subtract 1 and divide by 2. And to the nearest hundredth, x is approximately 0.54. Okay, I would like for you to pause the video, and I would like for you to try number 17, 18, and 19 on your own. And when you are finished, you can check your answers in the next step of the notes. Okay. We're going to go ahead and move on to example number 5. Okay. In example number 5, it says solve, round to the nearest hundredth. Again, I have exponential equations, so I'm going to change them to logarithmic equation. Again, this is a lengthy problem, and refer to page 193, example 5 in your textbook, in addition to my video notes for a detailed explanation. Okay. Once again, when we have an exponential equation, we need to change it to a logarithmic equation. So we are going to take the log of both sides. It is your choice to either use the common log or the natural log. You will get the same answer as long as you complete the calculations correctly. Okay, I'm going to take the natural log of both sides. So I have the natural log of 3 to the power 6x minus 3 equal to the natural log of 2 to the power 4 minus 4x. Now that I have a logarithmic equation, I'm going to use the power property so I can get the exponents in front of the log. The powers in front of the log. So on the left side, I'm going to move the quantity 6x minus 3 out front. So I have 6x minus 3 times the natural log of 3. And on the right side, the power 4 minus 4x will get moved to the front of the log, times the natural log of 2. Now, because I'm solving for x, my goal is to get all terms that contain an x on one side of the equation. But before I can do that, I need to distribute on both sides. On the left side, I'm going to distribute the natural log of 3. So I have 6x natural log of 3 minus 3 natural log of 3. On the right side, I want to distribute the natural log of 2. So I have 4 natural log 2 minus 4x natural log 2. Okay, next, any term that contains an x will be placed on the left side of the equation, and any term that does not contain an x will be placed on the right side of the equation. Okay, so on the left side, I already have 6x natural log of 3. I'm going to add 4x natural log of 2 to that side, which will bring it to a positive 4x natural log of 2. Now, on the right side, I already have 4 natural log 2. I'm going to add 3 natural log 3 to both sides. So this will be plus 3 natural log 3. Now, on the left-hand side, both terms contain an x. So I'm going to pull out a GCF of x, moving up here to the top. Okay, so if I factor out an x, I'm left with 6 natural log of 3 plus 4 natural log 2. And this is equal to 4 natural log 2 plus 3 natural log 3. Okay, next we're going to use the power property, and we're going to move the numbers in front of the log back to the power to create an exponent. Okay, so I have x times the natural log of 3 to the 6th power plus natural log 2 to the 4th power is equal to the natural log of 2 to the 4th power plus the natural log 3 to the 3rd power. Now that all of the exponents is a number to a power, I'm going to go ahead and calculate and get that value. So I have 3 to the 6th power. So if I calculate 3 to the 6th power, I get 729. So I have the natural log of 729 plus the natural log 2 to the 4th power is 16. This is equal to the natural log of 16 plus the natural log of 3 to the third power, which is 27. Okay. Now, on both sides of the equation, we are adding logs with the same base. I can combine those as single logs by multiplying the numbers together. So I have x times the natural log, and I'm going to take 729 times 16, and this is the natural log of 11,664. So I have combined those as a single log using the product property. I'm going to use the product property on the right side as well. So because I'm adding two logs with the same base, I can multiply 16 by 27 to get the natural log of 432. The last step to solve for x would be to divide both sides by the natural log of 11,664. So to get the value for x, I'm going to take the natural log of 432, close my parentheses, and divide by the natural log of 11,664. And x is approximately 0.65, rounded to the nearest hundredth. Okay, I would like for you to try number 21. So again, pause the video. When you're done pausing the video, I'm going to have you move down to example 6, and we will check our answers to the you try problems in just a little bit. All right, moving on to example number 6. Okay, we're going to solve exponential equations in quadratic form. Again, you can refer to page 193 in your textbook, example number 6, if you would like written instructions to solve these problems. Now to solve, we are going to apply quadratic techniques such as factoring or the quadratic formula. So number 23, we have e to the 2x power minus e to the x power minus 2 is equal to 0. Now, it's very challenging to try to solve this when I have exponents within this quadratic equation, okay? So what I'm going to do is I'm going to turn this into a quadratic equation that does not contain exponents with bases that are numbers like e. So to help me do this, I'm going to let u equal e to the x power. Okay. So what I'm going to do is I'm going to replace all e to the x power in this equation with u. If I do that, if I replace e to the x power with u, I get u squared. Minus, if I replace e to the x power with u, I get u. Minus 2 is equal to 0. This is an equation that I can factor. I know that u times u is u squared. And I know negative 2 times a positive 1 multiplies to make negative 2 and adds up to make negative 1. So I have u minus 2 and u plus 1. Now if I set each of those two quantities equal to 0, then I know that u is equal to a positive 2 and u is equal to a negative 1. Now to finish, I know that u is equal to e to the x power. So when I have u equal to 2, I can substitute e to the x power for u. So I know e to the x power is equal to 2. I now have an exponential equation. I'm going to change to a logarithmic equation by taking the natural log of both sides. So I have the natural log of e to the x power is equal to the natural log of 2. Now, the natural log of e to the x power is equal to x. So x is equal to the natural log of 2. So if I take on my calculator the natural log of 2, x is approximately 0.69. Now remember, we have two answers. U also equals -1. Again, u equals e to the x. So I now have e to the x power is equal to -1. Okay. Now this yields no solution. There's no way I can take e to a power and get a negative number. Okay. So anytime you have an exponent that gives us a negative number, it represents no solution. Okay. I would like for you to pause the video. Try problem numbers 24 and 25. Okay, when you finish those 6 examples from example 4, example 5, and example 6, I want you to go to part 2 of the notes that's listed in the assignment or in the notes page, and I want you to check your answers to those 6 problems. Good luck.